All right, this is chapter 17 on water pollution, and we are going to just start with some general concepts about water pollution. Uh, Natural sources of water contain more than just water molecules. As salt water, oceans contain all sorts of dissolved compounds, but so do lakes, streams, and groundwater in lesser amounts. Fresh water, technically, contains less than 1,000 milligrams of liter or milligrams per liter of dissolved solids. So that's fresh water. I forget what salt water's limit is, and then in between that, between fresh water and salt water limit is brackish water. Geochemical cycles. So, like you've heard of the water cycle, there are geochemical cycles too for all sorts of things where they come in and out of like solution with rocks. Here is an example of the calcium cycle. So it's showing calcium is derived from the weathering of rocks. It's dissolved away where it then runs into water. And then in the water, it can be taken up biologically and it's put into little shells and bones and things. And the animals here, it can just kind of precipitate down onto the floor, although a lot of times it's from the dead animals then falling down to the floor. Um, so seafloor sediments here, let's see, it can be subducted, where it's then put back into the crust, where then it then weathers away again and recycles. Also, once it gets down here and it's precipitated or fallen down to the floor of the ocean, you have all of this water. It can still be leached back into the water from there as well. And so other elements and rocks have kind of the same kind of thing. Like obviously salt would be very much the same as this because it can be dissolved as well. Residence time is how long a substance stays in that body of water, so in that reservoir. And it is defined as the capacity of the reservoir to hold that element divided by the rate of influx. So here are some definitions. Capacity is the maximum concentration of a substance that a reservoir can hold before saturation occurs. And then the rate of influx is how much of a substance a system brings into the reservoir. So the rate of influx would be, let's say it's a lake. How fast are the streams flowing that go into that lake would be the rate of influx. Also, if the lake isn't the final endpoint and there's a stream that comes out of that lake, like let's say it's a dammed area, so then what is the rate of the influx and the rate of the outflux? So what's coming out on the other side of the dam, and then the capacity, so how large is that lake? Um, and depending on the different chemicals and how quickly they become saturated and precipitate out or not is going to be the capacity. And then humans can alter the rate of influx or other parts of this equation by our activity. Residence times for many natural compounds are known and understood. Residence times for more complex chemicals and compounds are not well known. Chemical behavior of complex and synthetic compounds often need time to be studied and understood. And I think a lot of this, especially the synthetic, like later we'll talk about how many new chemicals are being created each year. There just isn't time to really understand, how long it takes for them to become saturated and things like that. Here are a couple diagrams. This is just showing the different pathways that trace elements. So trace elements are elements that are kind of in minor percentages. Um, it's not like oxygen, like in the air, like oxygen, nitrogen, these are all like major components. Trace elements are things that are just, tiny, tiny amounts in there. And it's just kind of saying that the trace elements found in rocks, these things occur, some of these elements occur naturally, the ones that aren't, synthetically made. And it can get to people via, the water, being taken up by crops and food and being eaten, being drank, and then through dust, it can come in through the air as well. Here's a dose response curve of fluoride where it shows that, like, even though a lot of fluoride is toxic, um, actually there's like this little range where it's actually good for you and it helps you with the development, prevents cavities and stuff of your teeth. A little bit higher than that, it actually hurts your teeth. So that's kind of interesting. I didn't know that. Um, but then, if you take way too much, it can kill you. So, just because something, I guess, I'm trying to say, so even though like fluoride can be toxic, in small doses, it's actually good. So it's like, don't freak out about every little thing. And a lot of times there's like almost like a quantum step where it's like inert, 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 and then oh, now over this amount, it's bad for you. There are not point and non-point pollution sources. So these pipes would be point sources because like, okay, this is being polluted from this spot right here. And okay, you plug this pipe and the pollution's going to go away. The non-point kind of come from more regional areas where you don't really know exactly where it's coming from. Like if this is just a whole bunch of farmland, is it just one farmer that's using that fertilizer? Is it all of them? Where's it really coming from? Um, and so you have to treat the sources differently, obviously. Um, all right, and that is it for general principles.